Welcome one and all to this 28th episode of D&D with me, Mike.
And me, Zoe.
And today we are going to add exits to all of our levels. So our little fella here starts in a castle where it's all safe and we can explore without getting hurt. We're probably going to put some objects here just to make it more interesting, but for now there's nothing. And then you can walk out.
And then you fall.
When we reach here, right, we are going to... Oh, I probably fell. Right, when we reach here, we're going to actually go to the north of here. Right?
Mm-hmm.
So step number one will be to just at least construct a single basic
level.
North place, right? We don't really have anything. But yeah. So there we go. Now one thing we need to do is...
Show the grid first.
That's right. We need to create the grid. View, show grid. We're not going to snap to it, but this is good enough, right?
Mm-hmm.
And now we can keep on constructing things. So say, for example, let's keep building a small wall. Pencil, color grabber. There, we've got the gray. Right, we're going to construct a few more pieces of wall. And that's it. And then we're going to need dirt. Grab some dirt, paint it all around. Okay, so what should we do? Now the goal for now is to create that sort of initial puzzle, right, where you're capable of picking up the bombs, right?
With the glove and the treasure and all that.
Yes. So let's see. We should sneak, right? And we should have some kind of barrier that doesn't allow us to go anywhere other than where we are. So yes, I suppose we'll begin by going like so. I'm improvising, right? So alright, so here we go. This is my little land.
Plop.
And I mean it's going to exit on these. Perhaps you should exit everywhere. Yeah, that could be good.
So you'll have to swim to the other side?
Yeah.
Unless you want to come here and then go all the way up.
Yeah, and just for now, let's just do this and then we're gonna start adding grass, right?
Mm-hmm.
So here's our grass. Whoops.
Colored in the other area.
Didn't mean that, but that's okay. It's no biggie. Okay,
now
so
plop the inside.
that's right. So we've got our grass area, etc. Right, and you can go on all of the sides, in theory anyway, to go and explore.
Now we need to add some bombs and the fortress.
Yeah, probably. Well, I mean, I wouldn't worry about that for now, in the sense that all I want for now is just create the transition, right? I'm not too concerned about whether the walls are going to work the way they're supposed to. Maybe we should have like sort of a room. Whoops. Hit Control Z for me, please. We should have a room that has multiple... a level that has multiple rooms. Hit Control C, Control V, 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 V.
Now we need to enter it.
And now cut, Control V, and then we're going to put it more towards the center. There, so something like this, right? And maybe all of these rooms may be enterable one way or the other, or something like that. But we'll worry about that later. One thing that we are going to do, though, real quick, is we're going to remove the grass from here. I think the inside of buildings should not have grass. Okay, so give this a save, Control S, and then Control Shift D. And we are going to our textures and map. Okay, and I think the rest stays untouched for now. So that's good enough for now. I'm bothered by something. My OCD isn't happy. There. Now I'm happy. Okay, here we go. So that's good. Save again and export again. This time you can just Control E because it's the same file. Okay, so now this file will be magically uploaded. So all we need to do now is figure out when we've hit the exit of a level. So to do that, there are several ways, I think, but we need to be a bit careful. I think the best way would be if we realize that we've jumped out. So if our character's, say, down ray doesn't hit anything and the center of the player is outside of the boundaries, then we
put it at the next.
Then we put it in the next spot based on which direction we've gone and based on the current position. So there's a few things we're going to have to worry about.
Mm-hmm.
All right.
Which means we have to delete that bridge that we just added in the map.
Why?
Because we can't fall in the down ray.
No, I don't think you understand how this works. When the game loads, the bridge is interrupted at the end of the quadrant. When you then cross that, you're going to teleport here as a character on the new map.
Oh, okay.
Does that make sense?
Yes.
Okay. All right. So, who should control that? Well, the player for sure. So let's go to the player, hit Control MO, just because there's too much going on here. Okay, so inside fixed update, there's the down ray. And the down ray starts the jump. If down ray, terrain state none, jump. Okay, well this will depend. So we're gonna check it right here. And we're gonna say, yeah, hit enter, go if, open round. And now we need to check that the coordinates of the player are within the limits of the map. Now, I'm not really, oh, wait a moment. No, yeah, that's correct. Are within the limit of the map.
32 and 64, I think it was.
Yes. But remember that that's the size. That means you need to take the middle, the middle point that you know is going to be 0. And then you need to subtract and add the size itself. But I'm not 100% sure this is how it's going to work. So let's quickly go back to the player and mute this, save. And let's go check, without maximize and play, the numbers, right? So if we're correct, then the top bit should be, if we click on player, observe the vector 3s, look at the Z, right? 18, 20, so we should get to 29, 30, 31. Yeah, we're basically at 31, and we're here, right? 31, 3,
and
then he jumped, right? But so that looked more like a 31 to me than it looked like a 32, you know?
Yeah.
So let's see here. So perhaps we could do that number minus 1 or something. Okay, so I'm at the very edge. Anyhow, I would say 31. We're already outside of the map. Yeah, 31 we can't see ourselves. That's where 31 would be.
Can't even see the business card.
There. And you'll see that it's not visible here. Yeah, you can't see yourself. Okay?
Mm-hmm.
And I think that's pretty good. So, save. Let's create a small method that checks if the player is within the boundaries inside the map. So here you're gonna say a public bool.
Boo is the thing that went.
You know what? We should get a cardinal. Yeah, so we want to know if it's north, south, or east or west.
What's
right?
a cardinal?
Cardinal, north, south, east, west. These are cardinals. So go public, enum, cardinal. Open a squiggle. Save. Yeah, sure, that's good. paste it there, hit enter, and go, let's start with west, north, east, south. South. That's enough, save. Okay, so instead of returning a bool, we're going to return a cardinal. And we're gonna call this one get player or get entity inside map. Open round. You need a, let's say, transform T. It needs to be capital, it's not gonna work that way. It's a variable type. So transform, hitting tab too early. Now it's not even working because you haven't started to work. Transform space T. Close round, open a squiggle, and close save. So it's gonna check if the transform is inside the map. So here we're going to say if T dot position dot Z. No, let's start with dot X. X is lower than, and you need to go and grab the quadrant size, copy, but first cast it as a float. Cast it as a float.
And then -1.
Float, yeah, a bit more than that. Quadrant size dot X. And so this one needs to be halved. So open a round bracket here and divide by 2. So you get an int division. 2. Close the round. Semicolon. Close the round again and open a squiggly. Hit enter. There. Save. So this is insufficient. This is lower than 32 at this time, right? But it needs to be negative. So we're gonna put a negative right here. Save. And now we also said we want a +1. So here you go, +1f. Right, save. So this means which direction are we in?
That.
If my x is lower than half, the negative of half of the width, therefore -32 + 1, so -31. If I'm further than -31, wait a moment. Wait. I just remembered something. We had 31 going up, so save for a moment. Save. Let's go test really quickly, because we had a 31, I'm almost sure, on the Z.
We did.
Yeah. So we start, maximize and play. I have a difficult relationship with that button. Okay, so we're at 0 now. No, we're not. We're at 9. Okay. So we're already positive. Aha, see, we're potatoes. The leftmost is 0. The problem is 0 isn't here in the middle. 0 is here. The bottom left corner is a 0. Watch. If you click on this thing, look at its position.
0, 0, 0, yeah.
That's right. And if you click on this thing, look at its position. 63, 31.
Yeah.
So that's the maximum. So that's we did it wrong. Okay? So what we need to check in order to go in whatever direction we're going now, well, I know the direction, but I want you to figure it out. Save. Okay, is not this. It's just lower than 0. Save. Right? So if it's lower than 0,
then we're going down.
No. Which axis are you looking at?
The X.
So
So
you're going
that's if
horizontal.
it's lower than 0, then you're going east, I think.
Wrong. East is right.
Oh, I meant left.
Yeah.
So
you're going
west,
west,
right?
Yes. So you're going west. So here you want to return, space, tab, dot, west, semicolon. Okay. Now copy this entire if, Paste it here.
Now I need to do
Again,
it for all the rest.
and again, save. And wait, if none of these works, copy this, paste it here, underscore none. Save. Okay. So return west, etc. If none of these conditions are met, then we return none. That means we haven't exited the map at all.
If it's higher than 0, we go east, right?
Well, not really, because it's not 0. If it's higher than 0, you're on the map. If it's higher than what, we go east. So type east here. Yeah, if it's higher than what number, we go east. Lower than 0, we go west. 0 is the bottom left part, well, the leftmost part of the map. What's the rightmost part of the map?
The rightmost part of the map is 31.
No.
Well, 63.
63, that's right. So if it's higher than, copy quadrant size, cast as float first. Okay, do it here. Float, and then dot x minus 1f. 1f, not yf. 1f.
Oh, I heard you say YF.
What would that mean?
Yeah.
Okay, if t position y is lower than 0, then we're
Now
going.
Basic.
No, z, not y. My bad. Z. So
Z
if our
is up.
if
Z
z is
this.
if z is lower than 0, where are we going?
We're going down.
So
Down.
there's no down.
Oh yeah. So south,
So
not down.
hello. South. Okay, there we go. And this one's gonna be north. So what check do we use here?
And north.
First of all, it's a z. Second of all, it's a higher than. Save.
And it's a 31.
Well, sure, but where is that 31?
So then wait. So
Load. Yeah.
and then
Quadrant size.
but this time dot y. Well, dot z.
No, dot y. It's a vector 2. Minus 1f.
To get 31 and not.
And now we're
32.
getting the north. Okay. So based on all these pieces of information, we know what to do now. Well, at least we can start to know what to do. And we're gonna call this query from the player right here. So when we lose connection to the ground, okay, we're then gonna say here if let's open a switch. So go switch. SW tap tab. Just tap tab. There you go. And here you wanna type map manager. No, just map dot script dot get whatever we said. Get entity, I believe. Yeah, inside map, open round, and feed it transform. So yourself, right?
Mm-hmm.
Close the round. Save. And now you can hit enter. So it gives you all of the things. Save. Alright, so for northwest, etc., we're worrying about it, but none is also important. So here hit default, colon. I don't know that I like this. Save. Yeah, I don't think I like this. Let's create a cardinal on the fly here. So go cardinal C. Yeah, cardinal C equals. Cut all of this. Paste it here. And type C, semicolon. Save. Right, so we're gonna check for C. If C is none, what do? We're inside the map. So what do we do if we have nothing under our ground and we're inside the map?
We go to the next level.
No, we're inside the map. We're still within our map, but there's nothing underneath us. What do?
We jump.
That's right. So cut jump, put it here. Save.
And then we have to do the rest.
Save again. Now, default, this is where we change the level. Okay, so let's check how we change the level. I think our guy over here. No, it's not. Oh, I'm surprised by these spaces. Save. So maybe it's in start. Let's see, load profile, setup map. Okay, map script, setup map, player attributes, spawn quadrant. Okay, so we need to change the player attributes to the next spawn quadrant depending on our
We only have 0 so far.
Hmm?
Of the spawn quadrants. We only have 0 saved in the player attributes.
I don't understand.
The first level.
Yeah, but the first level is not 0. The spawn quadrant first level, even if it's the first level, sorry, is something like, what, 113? I don't remember. I think it's 113, isn't it?
Yeah, because...
Yeah, 113. That's the first level.
Transition is 114.
That's right.
The second.
But we're not going to go with these arithmetic values. We're going to actually create formulas that will calculate that for us. Now we're going to use the map again for this. And here, you're going to say public. And you're going to request a vector2 int. And you're going to call it get next quadrant. Open round, request a cardinal. Call it C. We're also going to request something else. Vector2 int current quadrant. Or just Q. Q.
I think...
Yeah, go with the explicit current quadrant, agree. Current quadrant. It's going to be much clearer. Okay, cool. So now you have the current quadrant. We need to do certain calculations, and then you're going to have all sorts of crazy things. So let's first of all create a vector2 int that we can then return. This is a typical thing I do all the time. So type vector2 int, because that's what you want to return, right?
Yeah.
And call it returnable. Then hit a semicolon. Hit enter twice. Return returnable.
This is going to come last.
Exactly. Right? So here we're going to do all of our calculations. Right? So first of all, we're going to say switch. So SW tab. C tab. Enter. There. I didn't remember. Yeah. I didn't remember
Tab.
what button you were supposed to press. I think it was enter. Oh well. Save. Okay. So if we're going west, that means left, right? So if we're going left, what number of our quadrant coordinates should change?
If we're going left.
You're going left, right?
Uh-huh.
So you received a current quadrant. Let's say it's the first one. So it's 113. Which of these two numbers needs to change into what?
The 1 needs to change.
To what number?
Into 0.
Mm-hmm. So what's the operation to get a 1 to become a 0? You have a 1, you have a 0. What happens in the middle?
1 minus 1 is 0.
So going left is a -1 on which axis?
On the x.
Correct. Therefore, you want to say returnable equals, no, returnable, very different, equals current quadrant plus vector2 int dot left. Let's see if it exists. Dot left. Oh, it does. Okay. Semicolon. Now, not a huge fan of this, but it will work, right? Because this kind of invalidates what we were talking about, right? Removing 1, but there you go. That works anyway. So let's now copy this entire thing, paste it inside north, east, undo, again, and south. Save. So this should be fairly simple. If we're going north, where are we going?
We're going up.
And if we go east, where are we going?
We're going right.
And if we go south, we're going?
We are going down.
Aha.
If it's down.
Okay, so that's all perfect. Sorta. Something is wrong. Well, first of all, it's not happy because the first returnable doesn't exist. So it's not happy about that. But there's also another thing. If you're at x0 and you go west, what happens?
You go out.
You go out. And we're going to crash. We need to control that. So what we're going to do is we're going to create a Zelda concept. Well, no, we're going to clamp via level design, meaning we're not going to let our levels do this. But suppose you have a level that's entirely sort of a strip of water. right? Then we may let that happen. In order to let that happen, what we are going to do is we're going to wrap on the opposite side of the world. That's what happens in Wind Waker. In Wind Waker, you have a 7x7, if I recall correctly, which is 49 blocks, right? And if you go east all the way,
you'll end up
you spawn
on
west, the westmost point. So that's what we're going to do. So here you're going to say if open round returnable dot x is lower than 0. Oh, no, it's not a float, it's an int. So close round, open a squiggle, hit enter twice, close it. Okay, so if it's lower than 0, what we're going to give it is we're going to give it the highest possible x instead. So we're going to say returnable.x level.x equals and the highest guy is not it is the quadrant size. Okay, so copy quadrant size. Which one? .x.
We need the highest, so 64.
Yeah, which is x or y?
Which is x.
So .x. Do we need 64? The highest quadrant. Is its ID 64?
Think so.
Are you sure?
There's not 64 boxes, so no.
There are 64 boxes.
But it's 63.
Oh, plus, wait a moment. You're right. There are no 64 boxes because this is the size of the pixels, so I'm a potato. Right? We need to know the amount of boxes instead.
1, 2, 3.
It's 8.
Oh.
Yes. It's 8 and this one's going to be 16. Because if you divide 512 by 64, you're going to get 8. That's why working with powers of 2 is very, very nice. Oh, Captain. The student is Zoe. Okay, so let's see, where were we? Right, so not quadrant size, that's incorrect. In fact, it would be the maximum amount of pixels divided by quadrant size. Which, yeah, we're just going to assume that, you know? So it's not genius, this, but we're going to assume it. So here I want you to type serialize field, square bracket, serialize field, close square bracket, private, vector to int, map size. And yeah, go on new vector, yeah, equals new vector to int, open round, 512. No.
Oh.
Fair enough, really. I meant this. Comma 512. Yeah, close round, semicolon. Okay. So now copy map size. So paste it. Map size x divided by quadrant size x. Okay. Now save for a moment. Now let's check that this makes sense. Let's go to the calculator and go 512 divided by 64. 8.
Mm-hmm.
So is the highest returnable 8? Should it be 8? So you are here at 0. You go left and you end up here. Should it be 8?
Yes.
Let's try. 0, 1, 2, 3, 4, 5, 6, 7.
That's 7, not 8.
Why?
Because we start from 0.
Because you're 0 based. That's why I asked you before. So minus 1. Save. Alright. Else. Squiggle. Enter. Copy this entire if. Paste it here. Save. Now if returnable is instead higher than, well, higher or equal, rather. Copy all of this. Paste it here. So if it's higher or equal than 7, then what should be its value?
The value should be 8.
Okay.
7.
I know what I've said. Oh Jesus, it's like you're not paying any attention. So 0, 1, 2, 3, 4, 5, 6, 7, right? We're at 7. We transition to the right. We end up at 8. If the value is 8, where do we need to end up? Here. What's the value of this?
The value of that is 0.
There you go. So this is a 0. Okay. Now we need to repeat this with the Z. Copy. Paste. Save. Now do me a favor, because this guy's gonna keep on whining and it's really annoying. So just tell it equals vector2int.0. He wants default value. No, let's do something even better. Copy current quadrant and paste it. Save. There. And at this point we can simply say plus equals vector2 left. Replace this with a plus equals for me. And this. And this. Save. Alright. So now we dealt with the x, now let's deal with the y. So if y is lower than 0, then returnable y should be map size y divided by quadrant size y minus 1. Save. Let's see if this is correct. So map size y is 512 divided by 32. That's 16 minus 1. That makes 15. 15 should be the highest. Let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now I'm counting, I know this, right? I'm just counting to demonstrate to you. Put a y here, y, yeah, and y, and y. Is this already correct?
Yes.
Save.
Because it stays at 0.
And then returnable. So we're getting the new quadrant like this, and that's just fine. Now, in order to get the new quadrant, we got a new quadrant. What I also want is I want the new position in the correct place.
Okay.
So here we're going to create a public.
And we need to call these functions.
Vector3. And get next quadrant position. Quadrant position. Open request a cardinal, C, and request a vector3 position. Current position. Yeah. So we're consistent. Current position. Close round, open squiggle, hit enter twice, close and save. Ta-da! Okay. So here you go. Vector3 returnable. Vector3, that would work, but returnable semicolon. You can't type it. You can't tab it. You need to type this one. Semicolon. Hit enter twice. No. Good point, I guess. Current position. Hit enter twice. Yeah, forgot semicolon. Returnable. Semicolon. Okay, so here we go. And what we're gonna do now is we're gonna take whatever position we've got and we're gonna transpose it to the other side.
Okay. What does transpose mean, though?
Put it on the opposite side. We're also gonna give it a bit of padding.
So transport.
So here you go. Switch. Tab. C. Enter.
I'll press tab this time.
Remove this. And remove this. Save. So, if we're going west, which means left, we already know, save, we already know that we are lower than 0, right?
Yeah.
So, that means that we need to place the player on a different x on the opposite side, but the same y, well, z, right? The z won't change. Does that make sense? Okay? So, we're going to keep the y untouched, but the z must go opposite. Rather, we're going to keep the y untouched, we're going to keep the z untouched, and we're going to move the x. Therefore, what you want to do is you want to do returnable plus equals. Actually, I'm a bit worried about this. No, it'll be okay. So we're going left, and we're already at 0. In order to end up on the opposite side, what number do we need to have?
The opposite side of the
quadrant.
level, or
The quadrant.
we need to move it by 63.
That's right. So plus equals vector 3 dot right times float, cast as a float, close, copy,
This time
paste,
we're actually using
dot
this.
x.
-1.
Yeah, but you want it right here. So -1, there's still an int, so just -1. No, inside the brackets. -1. So the float cast applies to both. Semicolon. Now I have a worry. Because 63 is a position in may be incorrect. So we're gonna experiment with this really quickly. We're gonna take our player and hit W. Oh no, you don't need to. It's already there. Bluff. I've dropped my player over here. I'm going for a swim. See you later. Okay, 64. Have I fallen? Yes, I have. So 63.
Put him back.
So 63 would be here. So you just see him as he enters, which I think is a good enough place, really. You see, he puts him safely in the middle of the tile, right? Yeah. Okay, so that's good. That's what I wanted to experiment with. So this is 63. So we're adding 63 to whatever number. I'm not so sure about the whole adding, you know. So let's change this a little bit. Here, type .x equals. Save. So we're simply saying that .x is going to be equal to 63, and that's the end of the story.
Okay. Now we have to
copy this entire thing, paste it here, and here, and here. Save. So here for north, the Z changes, and it's going to be Z. Save. Now we're going north. That means that the Z is actually going to be 0. 0F. Now we're going east. It's going to be 0F. You respawn at west. 0F. It's like flour. Okay?
What's
and
a flour?
Flour, you know, the one that you used to bake.
Oh, flour.
Z and Z. Y, rather. Quadrant size is a vector 2 int. Save. Okay?
No, wait.
Just type
I
Y.
pressed
No,
Z.
save. Now, do we have to worry? Save. Do we have to worry about anything else here? Do we have to worry about wrapping or anything?
No, because we're just dealing for one quadrant, right?
That's right. We're literally setting the positions ourselves, so there's no worry about it. This is all information about where you are within that quadrant, so that doesn't matter. Okay, good.
We need to call these functions.
I am fully aware of that. So now the player has done the jumping, right? If any other thing happens, though, the player will not jump. The player will instead teleport and change level.
Mm-hmm.
Okay, so we're gonna go to change quadrant. So let's create a public void in game manager. Change quadrant. Request a cardinal C, then comma. You also want a vector 2 int current quadrant and a vector 3 current position. Current position. Close the round, open a squiggle, enter twice, close it, save. Alright, so change quadrant. Copy change quadrant, paste it here, open a round, and rather, my bad, copy all of this, paste it here. Okay, so change quadrant. Now it needs the cardinal, so you want to feed it C, comma. Current quadrant is going to be player properties, whatever it was. What do we call it? Whatchamacallit?
Player attributes, I think.
That's it. And type player attributes. I suspect that's what they're called. Do you see them? Because I'm blind.
I can't see him.
I wonder if all of the player attributes are somewhere else. Wait, there's gotta be information here. Somewhere. Where are you?
You could do the find.
Yeah, sure. Sure. No, wait. There's a setup, isn't there? Yeah, setup attributes. There you go. Oh, thank you. So that's it. No, that's not it. So setup attributes, it just does health and max health and whatever. This is annoying. Okay. Well, at any rate, it's going to be copy this, paste it here, dot player attributes. There you go, and dot quadrant. There, spawn quadrant. No, see that I don't like that. That's not it. That's not right. That is not right. Okay, let's see. Start, blah, 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 blah. Player, instantiate, blah, 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 blah. Setup map with player, spawn, quadrant. Does the player attributes have a current quadrant? I'd be very surprised. No, it doesn't, which is kind of what I expected. So I think our player should have this information. State. So here you go private. Should it be private? Private vector to int. Vector to int. Current quadrant. Semicolon. And you also, do you want anything else? No, I don't think so. So copy current quadrant. Now we need to make absolutely sure that it's all correctly set up right here. So paste it here. Copy all of this. Undo. Copy. Paste. Quadrant, spawn quadrant, where it's called spawn quadrant, I think. There it is. No. No, attributes. Player attributes. Dot spawn quadrant. There. Semicolon. I mean tab. Save. And copy. Paste. Equals. Map. Dot script. Dot get next quadrant. Oh no, wait, we're not gonna do this. My bad. Feed it current quadrant here, comma, and transform dot position. Close the round. Semicolon. Okay, so we fed all of this to the game manager. Now the game manager has received this information and it can process it here. So let me see here. So change quadrant. We are going to have to store this information and send it to the player then. So the player should have some kind of hit control MO. Should have some kind of interaction that allows it to teleport. So here you go. Public void. Teleport player. and request a vector to int quadrant and comma vector 3 position. Position. Close round, open a squiggle, hit enter twice. So one problem that we're gonna have with the player is all of this stuff. So suppose the player is opening the chest or picking up a thing or climbing the ladder or whatever. All of these need to be interrupted. Well, one of them in particular, if the player is carrying something or all of these things, it's something we're going to have to worry about. It's going to be important.
If you tried to carry something in the other place.
Yeah. Now,
It'll
for
make you
now,
drop
we're
it.
not going to change anything there yet, but this stuff is going to be important. Okay, so step number 1 is we're going to tell the player that his rigid body is going to have an annulled velocity. So go RB dot velocity equals vector 3.0. Okay, the same goes for angular velocity. So go RB dot angular velocity. So even rotations. Yeah, copy this entire thing here. Pasta it. Okay, save. Now, current quadrant equals quadrant. Yeah. And transform dot position equals position. Semicolon. Okay, so here we're gonna teleport the player. Now here we're gonna do the teleport player when we have this information ready. So first of all, we're gonna hit vector. We're gonna write a vector to int q for the quadrant equals map dot script dot get next quadrant open round c comma current quadrant. Close round, semicolon. Enter. Vector 3, pause, or just p, equals map.script.get next quadrant position. Get next quadrant position, one down. I missed position, open round, c, comma, current position. Nope, position. Close the round, semicolon. Enter. Now, do we have access to the player? I would think so, but let's check. Yes, so player dot lowercase. Dot, what are we gonna do next? Script? No, I don't think so, just teleport. There, teleport player, open round. And you want to feed it the Q and then comma C. Oh, P rather. P. Close round. Semicolon. Looks like an emoji. It's like a guy with a very big nose. And yeah. I don't know.
Yeah.
He's crying from an eye. Okay, save. So change quadrant. Alright, so this may already work. Let's see if this is going to function. So I'm gonna hit play.
Warnings, but who cares?
No up. Okay, so it's kinda sorta worked, but it has loaded the wrong map, which is interesting, right? Oh, I know why. Because we forgot
have the map.
we haven't loaded the map at all. These were potatoes. So copy this entire thing. Paste it right here. And instead of spawn quadrant, you want to feed it Q. Save. So now it's going to load the new map. It hopefully will destroy this one. If we haven't been idiotic, we have actually included a part to destroy the map.
And we have. And we're going back. The fortress, which is unable to get into.
I know, but it's working. So one thing I'm not super happy about is that it takes a bit. And it's normal because it needs to reinstantiate all of these blocks all the time. Let's see the stats here real quick. Whoa, 8,000 batches.
Where is it?
It's because we're not grouping any of the meshes, so.
But where is the batches?
Right here.
Oh yeah.
It's a lot of draw calls. There's 1,000,000 triangles. It's not exactly very clever what we're doing. the grass is causing us a lot of grief. You know what? Let's
change it up.
Let's quickly do something about this, because we've done this and it kind of works now. So let's go to the environment. So what we're gonna do probably is we're gonna introduce the concept of textures soon, right? Because see, the problem with this dirt is that it's really expensive. Now you could simply splat a texture on it that looks exactly like this.
Dirt.
That looks exactly like this, and you'll be perfectly happy.
Same for the grass.
That's right. So let's just do this for now. Hit Tab, Z, A, B, delete vertices. Okay, Tab. This is the teleportation. We'll leave it alone.
That's not a teleportation. That's a spawn point. But whatever.
Sure. Tab. B. Delete. The delete key. It's always in the same place. Done. Alright, tab. We're gonna leave the wall alone for now. Yeah, okay. And where's the C? Oh, hello. Okay, anyway, save. I just thought that the C could lose a couple of vertices. Yeah, hit tab. Hold alt.
Oh, that's control, wait.
Delete vertices. So just delete enter. There you go. Control S to save. Alright. Now we should have reduced the amount of vertices dramatically.
Batches are 5.
Well, nothing's loaded, potato. Batch is still going to be high, but the number of tries has gone down by 500,000. So.
Yeah. Oh.
And as you can see, the loss of quality is relatively minimal. What we need to do is we need to create textures for this. We should create textures for.
How do you do that?
Well, basically, you create a picture. You create a picture and you slap it on top of the object.
Okay, but...
It's not that difficult. I'll show you how. We're also going to use a tool. But we can't. That's a paid tool. I can't use any paid tools.
Why can't you use a paid
tool? Well, maybe
tool?
I can. Well, because I'm trying to teach something to someone, and, you know, if you need to pay for it, then you've got a problem.
Yeah.
So there's a few things that can be improved here, that can be optimized. And we can merge the meshes, by the way. I wonder if we could try that right now. Let's give it a shot. I don't remember how you do it, but we had tried it last time. So when you set up the map, before you set up the entities, right here.
It was commented out somewhere.
Yeah, but I've deleted it since. So it's going to be
static batching utility, I think.
Something like that, yeah. There should be a container. Where is that container? Do we have a container or not? Entity containers. Map containers. Okay, copy all of this. 4 tab. Paste dot length. Yeah, tab. Actually, I don't like this, but anyway. No, I like this. The map should be safe. Wait a second though. Let's just... Oh, transform. There you go. Easy. Save. So try that, what he said, static batching utility or whatever. Static... there it is. Static batching. Good call. Dot. Combine. Open round. Game object. Yeah, close round. Save. So let's see if this works. Because this usually is a process that takes a bit, but it may be acceptable considering you have a lot less. Okay, so they're all. So we've reduced this draw calls to 4,000, right, which is a lot less, and it's all combined now. Never mind, we reduced the batches to 200. I'm happy with that. That's a good number. So let's transition now. See how long it takes. See what I mean? Takes a while. That's the problem. So it's better for performance while you play, but it takes a while to do. Here we're gonna need step ladders, and let's see now. Splash, and I go to the other side.
You start swimming on the other side. That could be actually a good trick if there's a hidden island that you can't reach from one level.
Yes, that's the whole point of all of this, right?
Can't see yourself there.
Yeah, well, that's because oh, hello. I'm under
the wall.
I'm under the wall. That's
under
right.
the wall.
And I think I just went to the next side. Did I? Where am I? Okay. Or maybe there's no collider on the sides. That could be a possibility. Where's the player? Hello. Yeah, he's fallen. He's fallen forever.
Oh.
Yeah. Let's put him at 2. Let's find him. Yes, so he's under the wall and he's crossed. You see here? Because under the wall there's nothing, but you're still inside the level. That's something we're just going to have to look into.
Yeah,
fixing the walls.
Maybe you could just add the... I'm pretty sure we added the walls before the dirt.
Sure. I mean, the way it works is you can only add one object per quadrant. So the wall should be designed in a different fashion. But with the fact that we've now decided to actually reduce the poly count, yeah, it's, we should stick with this theory and go with that. So I like this grouping, but we still have the problem that we have excessive detail, so the grouping takes ages, right? I mean, ages is not exactly accurate, but it does take a substantial amount of time. As
ages as it took to load the 512.
Yes, but you can see how long it takes, right? And it's quite substantial. I mean, I don't know that I want to play a game that forces me to wait all this time every time, right? But it is substantially better optimized. But then again, if you simplify the water, for example, you'll see that all of this or most of this goes away. And I think we kind of should, frankly. Okay, because in the end of the day, we're not necessarily married to this look, are we? If it looks a bit different, it's fine. So we could do that instead. I this is one personal problem that I have with Magic of Voxel all the time, which is Magic of Voxel produces drastically unoptimized meshes. So if you start to have a lot of them, your game really, really seriously begins to chug, and you need to start worrying about optimization very, very soon. Right? For example, the shadow drawing. You see how complicated it is. Right? So you would need to, for example, replace all of the shadows of a cube as plane shadows. Let's give that a shot, right? Just so you can see how this functions.
Or just turn them off.
If you turn them off, then it's going to be ugly. Shadows are sort of almost a necessary thing for human beings to have to understand 3D. So let's go to the map.
999 plus warnings.
More materials than subsets. Ooh, that's interesting. Yes, so I think our grass had multiple materials, but it doesn't actually have them. Yeah, that's a fix we need to do now. See? Grass and grass blades. But that's not true anymore. Because
now go to
the dirt, same thing. Yeah, let's quickly do...
Several. Top dirt, bottom dirt, dirt.
Yeah, these are all of those warnings. So maybe the batching is actually longer because of that thing, So let's try the wall.
Need to do the shadows.
Yeah, but I also need to... Oh no, the wall still has both. Anyway, so we got the model, right? Now, duplicate model. And call this one shadow model. Okay, now the model, I'm gonna see how it says cast shadows and turn off. Okay, and receive shadows though needs to be on. Okay, and the way you cast shadows, you cast them with a shadow object. So instead of wall, you put a cube.
Okay.
Is there a generic cube?
Generic cube.
There you go. So it's a little bit further down. Easy. Drag it up to 0.5. Okay, just like that. And then you tell it, instead of cast shadows on, receive shadows off. And then just put one material. We don't need many.
Just bricks.
And what you need is oh dear, where is it? Cast shadows on, shadows only. That's it. So now it only casts shadows and nothing else. Okay, so let's test this. And you'll see how it looks like. You'll see that now all the shadows are straight, as opposed to being all jagged.
Yeah.
Okay, and we've lost another 30 batches. We've also lost a lot of tries. Right, we were at 1 million, we're now at 600,000. Now let's see. Okay, it's long, but improved a little bit.
We
right?
can make like...
We can make the walls a lot simpler. We're going to cover this next time. We're going to do some optimization. Also, we're going to change the sea and we're going to make the sea move a little bit, so it looks a little bit better. So there's a bunch of things we can do, right? But we are going to texture all of our stuff.
Okay.
Yeah, so it looks substantially better, right?
So the grass looks like grass again and not just hard floor.
Yeah, something like that. This little fella as he runs.
He can't even enter the fortress.
He can't. We have blocked him.
The bombs have blocked him and then escaped.
Look at him as he looks around. It's closed. Open the door. Batches 95. Yeah, that's a good number, right?
Mm-hmm.
And now, for example, if we go to the next world, north,
You fall.
we fall
In the sea.
in the sea, in the endless sea of endless. So let's see, what quadrant are we on right now? We are here. So the next one should be quadrant 0 or whatever.
Let's see the rapier.
So I don't know if we have anything that will do that for us. Contextual instance, throw strength, throw inertial multiplier, jump strength. I don't see anything in the player that indicates that information. I think we put it private. Did we? Yeah, it's private, so you can't see it. But we'll at least see if we are correctly going to the other side. No problem.
We're on the...
Yes. So now what we're gonna do is we're gonna go. So theoretically, right, we should be here now.
Mm-hmm.
So we're gonna go here, then down by 2, and then right, and we should end up, well, having problems. Well, we're gonna go down. So we're gonna go left by 1, then down, 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 right. Okay.
And we're back at home.
Theoretically. So left by 1, down, down.
And then we should down right.
He's swimming a lot.
He really knows how to swim.
Right. Yes.
Ta-da!
We are home. See, the whole thing is working perfectly, except if you walk out. No, that's good. It blocks us. But under the walls, yeah, you can see it from here.
Yeah.
Oh, right. Here I need to cross and then cross back in. That's funny. And
I am dead.
falling into
Dun,
infinity.
dun.
Well, that'll be enough for us tonight. Thanks for watching, and we'll see you again next time.
Bye.